Hello everyone, it's really good to see you here. So today we are going to solve a Leetcode problem, which is find minimum in rotated sorted array. So what we have given here, we have given an array which is actually rotated and is it in a sorted order form. And what we have to do is we have to find the minimum element inside it. So how we can approach this problem is that, let's suppose we have this particular given array. So here the very simple approach which we can use is that we can simply traverse throughout the array and find out which one is the minimum using an integer value, initializing it with int max, and then iterating over the array and just changing the value of our initialized integer answer, which is initially int max, and we change it to the minimum one. And at the end of our traversal, we find the minimum value. But what we have to do is we have to don't use O of n time, but instead of that, we can do it in O of n in O of log n time by using binary search. So how we can do is, let's suppose we have two pointers, left and right, and a midpoint. So you can see that mid is basically L plus R by 2. So in this case, our mid element is 5. So now here we have to check three conditions. So the base case for our traversal is that, let's suppose here you can see that 1 is the required answer, right? And if you check that 1 is less than 5 and 1 is also less than 2, and 1 is the single element which has these properties. If we talk about 4, then 4 is obviously greater than 3, but it is less than 5. But in this case, for 1, it's always the case that whichever is the minimum element, it is always smaller than all the elements or all the neighbor elements. So we can use this condition to check the base case. So the base case is this one. So we are using a previous. Previous is basically representing the index m minus 1, and next is representing m plus 1. But in this case, we have to keep in mind that our previous may be, let's suppose our m is here, so previous may go out of bound. So what we do, we just make it as m plus n. So what we do, we just make it m plus n minus 1 whole modulo n. So by this, we get an index of our previous one, and similarly for the next. Since next is m plus 1, so we just take the modulo of it, because there may be possibility that in this case, this m goes here, so our m plus 1 goes out of bound. So that's why we are keeping that in mind, and we are making just taking modulo of it with n. So by this we got our previous and next. So if this condition satisfies that our minimum value, our previous is also greater than it, and our next is also greater than it, so what we do, we just simply return m. So this is the base case. But if this is not the case, then what we have to check, firstly, if our value at index m is less than value at index r, then what we do, we just make r is equal to m minus 1. So what I mean here is that, let's suppose in this case m is here, l is here, and r is here. So the value of at m is obviously greater than the value at r. That means this is not a sorted, that means you can see that this is not a sorted array or sub array of the given array. So here we what we have to do, we have to check the second condition, that is, if our left is less than the value at let's suppose nums of L is less than value at nums of M, then this means that the whole array is sorted. So in this case, what we do, we just make RL as M plus 1. So now our M goes from here to here. That means our M is now here. So sorry, our L is now, so L is firstly here. Now L goes from this position to M plus 1th position. Now since L is here, R is here, so we can say that M also is at this position. So in this case, if we check the condition that m is at this place, previous is at this place, next is at this place, so it satisfies the condition, that is our base condition, that is the value at previous is greater than m, as well as the value at next is also greater than m. That's why we return the index m, and simply we have to return the nums of m as our answer. So this is the overall approach. Now in this case, uh, we we have to consider this when our left array is sorted, or we can say that from mid to our sub array is sorted, and this condition is to use when we can find that our array sub array which is starting from L and goes to till M is in sorted form. So whenever we found a sorted array, then we just make our pointers, or in this case, let's suppose if left array sorted, then we make L goes to this position. And in the same way, if our right array is sorted, then in this case, we just make our right as m minus 1. So this is not possible in this case. That's why we are not doing it. And by this way, we get our required answer. So now let's dive into the coding part of it. So here I had initialize another function naming index, and it takes a vector integer as a input. So what we firstly do, we just take n, which is the size of the nums, and L is basically representing the 0th index, and R is n minus 1. Then what we do, we just iterate through a while loop for the condition till the point L is less than equal to R, and our mid is L plus R by 2. So as I told you earlier that our previous is m minus 1 plus n. So we are doing this plus n here just because the case when, let's suppose m is 0, so we got this value minus 1, but this is not a case because we cannot do modulo then. That's why we are adding n to be on the safer side. In the same way, m plus 1 modulo n gives our next. Now what we do, we just check our base condition, that is if our nums m is less than nums previous, and at the same time nums m is also less than equal to nums next, then we simply return m as our answer index. And if this is not the case, then we check that if our right sub-array is sorted, so if our value at nums m, that is mid, is less than value of nums end, that is right, then we change our right as m minus 1. And if this is not the case, then we check the other condition, that is if our nums L is less than nums M, then we just make our left as M plus 1. And if this whole doesn't give our any return value M, then we simply return 0. So what we do, we just call this function here. So I'm initializing int I, which is equal to index nums. So this gives the index of the smallest value, and at the end we have to simply return the nums I. So let's try to submit this out. It got accepted. So this is the approach to solve the problem, find minimum in rotated sorted array. And if you want to assess the code, then you can check the GitHub link given in the description. And this is it for this video. Thanks for watching.